Lewis structures. To draw the Lewis structures of a compound, we follow these steps. First step is to calculate the total number of valence electrons of atom in a compound, and second step is to select the central atom with lowest electronegativity, and the final step is to draw the skeleton structure in which we connect the remaining atom to the central atom through a single bond in the compound. Let me take one example here, that is carbonyl dichloride, and its chemical formula is CCl2O. To draw its Lewis structure, we follow this step. First, we follow first step, that is to calculate the total number of valence electrons. Here we have carbon, and so there is only one carbon. Carbon has 4 valence electrons because it is present in fourth group. The number of group represents the number of valence electrons in an atom. That is why carbon has 4 valence electrons being present in fourth group in the periodic table. And next atom is a Cl atom, chlorine. It is a halogen atom, and halogens are present in seventh group in the periodic table. That is why it has 7 valence electrons. There are 2 Cl atoms in this compound. That's why we multiply by 2. 7 2 is 14, and 2 Cl atoms have 14 valence electrons. Next atom is oxygen atom. Oxygen is present in 6th group in the periodic table. That's why it has 6 valence electrons. Now we add these numbers up. 6 plus 4 is equal to 10, and 10 plus 14 is equal to 24. The total number of valence electrons in carbonyl dichloride are 24. And next step is to select the central atom. Central atom is selected, that atom which has lowest electronegativity, and here there are 3 types of atom present in this compound: carbon, chlorine, Cl, and oxygen. We know that the electronegativity of atoms increases from left to right in the periodic table. Then order of increasing of electronegativity among these atoms is: Cl is more electronegative than carbon atom, and oxygen is more electronegative than Cl atom. Here carbon being the lowest electronegative atom in this series of atom is selected as the central atom. Now we follow the final step, that is to draw the skeleton structure, in which we connect the remaining atom to the central atom, that is the carbon atom. Let me draw carbon atom here. Here we have carbon, and the remaining atoms are 2 Cl atoms and 1 oxygen atom. We connected to central atom. Well, Cl atom. Now the oxygen atom we connect oxygen atom also to the central atom, and finally we satisfy the valency of these atoms. Let me take the central atom, that is carbon. Carbon has 4 valence electrons, and you can see that carbon is forming 3 bonds. It means that it has used 3 out of 4 valence electron in forming 3 bonds. To satisfy its valency, it forms double bond with this oxygen atom. Now its valency is satisfied. Now let me take oxygen atom. Oxygen atom has 6 valence electron, and here you can see that oxygen is forming double bonds. It means that it has used 2 out of 6 valence electrons in forming double bonds. Now oxygen atom is left with 4 valence electrons. These valence electrons are shown in the form of dots. Now chlorine part, chlorine atom has a 7 valence electron, and here you can see that each chlorine atom is forming single bond by using its 1 out of 7 valence electron. Then each chlorine atom is left with 6 valence electron, so in the form of dots. A pair of dots is considered as a lone pair, and these are the electrons, these are the dots or electrons which do not take part in the bond formation. To check whether this diagram satisfies the total valency of carbonyl dichloride, we calculate the total number of electrons shown in this diagram. Well, here we have one oxygen atom, and one oxygen atom shows 4 dots, means 4 electrons. Here we have 4. There are 2 chlorine atoms mentioned here too, and see each chlorine atom is shown with 6 dots, means 6 electrons, 6 2 is 12. And number of bonds, there are 1 2 3 4 bonds are there, and each bond has 2 electrons. 4 2 is 8. Now we can add these numbers up. 12 plus 8 is equal to 20, and 20 plus 4 is equal to 24. Here you can see that it satisfies the total valency of electrons of carbonyl dichloride. This is the Lewis structure of carbonyl dichloride. Let me take one more example, that is iodic acid, and its chemical formula is HiO3. And to draw its Lewis structure, we follow the same steps. First is to calculate the total number of valence electron. Hydrogen obviously has 1 valence electron, and iodine is a halogen atom, and halogens are present in 7th group in the periodic table. That is why it has 7 valence electrons. Oxygen part, next atom is oxygen. Oxygen is present in 6th group. Obviously it has 6 valence electrons. Well, there are 3 oxygen atoms present in this compound. That is why we multiply by 3, and 6 3 is 18. Now 3 oxygen atoms have 18 valence electrons. Now we can add these numbers up. 7 plus 1 is equal to 8, and 8 plus 18 is equal to 26. The total number of valence electrons present in iodic acid are 26. Now we follow the second step. Well, in the second step is to select the central atom. There are 3 types of hydrogen. 3 types of atoms are present in iodic acid. One is hydrogen, second is iodine, and third is oxygen atom. Well, a central atom is always selected that atom which has lowest electronegativity except hydrogen. Hydrogen is not considered as a central atom because it has only 1 valence electron. Therefore, it cannot form more than 1 bond. And despite the fact it being the lowest electronegative atom in the periodic table, it is not considered as the central atom. Now we are left with 2 atoms, and now we compare their electronegativity, iodine and oxygen. And we know that the electronegativity increases from left to right in the periodic table. Oxygen is more electronegative than iodine. Iodine is taken as the central atom, being less electronegative than oxygen atom. The final step is to draw the skeleton structure in which we connect the remaining atoms to the central atom, that is iodine. Let me draw iodine here. Well, remember, if a compound is having hydrogen and oxygen atoms, we make possible pair of hydroxyl group. There is only 1 hydrogen and 3 oxygen atoms. Only 1 hydroxyl group is possible, and we connect this hydroxyl group directly to central atom. Now we are left with the 2 oxygen atoms, and these oxygen atoms are also connected to central atom. Finally, we satisfy the valency of these atoms. Well, let me take the central atom, that is iodine. Iodine has 7 valence electrons, and here you can see that it is forming 3 bonds. It means that it has used 3 out of 7 valence electrons in forming 3 bonds. To satisfy its valency, it forms a double bond with these 2 oxygen atoms. Still, it is left with the 2 more valence electrons. These extra valence electrons are shown with the dots. It is a pair of dots, means it is a lone pair electron which do not take part in the bond formation. Now let me take oxygen part. Here you can see that this oxygen is forming double bond as well as this oxygen too, and this oxygen is also forming 2 bonds, means each oxygen atom is forming the equal number of bonds. These 2 are forming double bonds, and this oxygen atom is forming 2 bonds. Means each oxygen atom has used 2 out of 6 valence electron in forming 2 bonds or double bond. means that each oxygen atom is left with 4 electrons, 4 valence electrons, and these valence electrons are shown in the form of dots. Here we show 4 dots, and these are the dots, these are the electrons which do not take part in the bond formation. To check whether this diagram satisfies the total valency of iodic acid, we calculate the total number of electrons shown in this diagram. Well, let me take iodine. There is only one iodine. I mentioned here 1, and iodine shows 2 dots, means 2 electrons. Here we have 2, and oxygen part, there are 3 oxygen atoms. I mentioned here 3, and each oxygen atom shows 4 dots, means 4 electrons. 3, 4, 0, 12, and the number of bonds 1, 2, 3, 4, 5, 6. There are 6 bonds, and each bond has 2 electrons. 6, 2, 0, 12. Now we can add these numbers of 12 plus 12 is equal to 24, and 24 plus 2 is equal to 26. Well, the total number of valence electrons are 26 in iodic acid. Now you can see that it satisfies the total number of valences of total valency of electrons in iodic acid. This is the Lewis structure of iodic acid. Well, since we have shown this diagram with dots, and that is why this diagram is also known as Lewis dot structure.